Most people believe the iPhone keyboard was born from genius. And it was. But in 2005, Apple had no keyboard that worked. If they couldn't solve typing on glass, the entire iPhone project would die. So Steve Jobs paused every other UI effort and forced one rule: show your work. Every other day, 15 engineers had to demonstrate prototype keyboards live in front of the entire department. They called it the Keyboard Derby. And it's the clearest example in modern tech history that process doesn't kill creativity. It creates it, especially when that process is transparent. Let's get into it. When most people hear the word process, they think of something rigid, checklists, approvals, bureaucracy. It feels like the opposite of creativity. Creativity, after all, is supposed to be spontaneous and free. But the truth is, every creative breakthrough hides a process beneath it, a structure that channels imagination into form. The difference is creative processes are rarely visible. The mess gets hidden from most of us. These iterations are erased. The final product looks inevitable. But that illusion feeds a dangerous myth that process kills creativity. In reality, process accelerates creativity, especially when it's transparent. And the idea is actually 400 years old. I read this amazing book by Laura Fermi about Galileo. And in it, I learned that Galileo created transparency. See, centuries before anyone used the word innovation, Galileo confronted the same kind of tension between imagination and reality. As Fermi puts it, what Galileo learned turned him gradually against the well-established tradition. His teachers studied science only in books. Scholars who studied it from nature stopped too often at the observation of natural phenomenon and did not make scientific experiments in the sense accepted in modern science. Galileo instead invented experiments, considered them a necessary regular practice, and came to regard them as the criterion in discriminating between the unlimited possibilities of human imagination and the reality of the physical world. See, Galileo didn't just dream. He built a process. He built a process to test dreams against the realities of the physical world. His experiments made discovery transparent, visible, measurable, and repeatable. This is a process we now call the scientific method. Now, one of his famous demonstrations involved dropping unequal weights of the same material from the Leaning Tower of Pisa. Pisa? And he proved that these objects would strike the ground at the very same time. All right, this was demonstrated by Brian Cox here, right? He's going to drop a cannonball and some feathers at the same time. He's going to do this twice. The first time he's going to do it with air in the room. So the cannonball falls a lot faster than the feathers, of course, because of the wind resistance. And this is what everybody in the world was seeing, right? And Galileo was saying, nah, this is going to be different. I think that gravity is going to have a consistent acceleration, which nobody believed. And so Brian Cox, because he's Brian Cox, he's got access to this amazing room here where they pull a complete vacuum in here, and now they're dropping both at the same time in this vacuum. And amazingly, and I don't know why this video, I feel like there's a missed opportunity in this video to actually show these falling at normal speed here. That's what a lot of comments say as well. But, you see this cannonball or this bowling ball and these feathers falling at the exact same rate. They're going to hit the ground at the exact same time. This demonstration proves the physics. This is what Galileo was demonstrating at the Leaning Tower of Pisa. And astronaut David Scott also recreated this on the moon in Apollo 15 mission. Here he is. So he's going to drop a hammer and a feather at the same time on the moon.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that?
The hammer and the feather hit the lunar surface together just as Galileo had predicted 400 years ago, just as his demonstration proved it would from the Leaning Tower of Pisa. Galileo showed that creativity without transparency is fantasy, but creativity with transparency becomes science. So how does this apply to your team? Well, we meet our next story in 2005. This is a story of the keyboard derby. This is from the iPhone's development. And what I want to illustrate here is transparency in a creative process. Here's the scene. 15 engineers from Apple's user interface department sit in a conference room called Between in October 2005. Across the hall were conference rooms named A Rock and A Hard Place. The names were whimsical, but the stakes were high. If they couldn't figure out typing on a keyboard, Project Purple, Apple's secret iPhone effort, was in trouble. If the team could not solve one problem, the problem of typing on a touchscreen keyboard, the project would be canceled. Steve Jobs envisioned a smartphone without the stupid keyboard. Physical keys, as he said in the 2007 keynote unveiling the product, were the problem.
Now, why do we need a revolutionary user interface? I mean, here's 4 smartphones, right? Motorola Q, the BlackBerry, Palm Treo, Nokia E62, the usual suspects. And what's wrong with their user interfaces? Well, the problem with them is really sort of in the bottom 40 there. It's this stuff right here. They all have these keyboards that are there whether you need them or not to be there. And they all have these control buttons that are fixed in plastic and are the same for every application. Well, every application wants a slightly different user interface, a slightly optimized set of buttons just for it. And what happens if you think of a great idea 6 months from now? You can't run around and add a button to these things. They're already shipped. So what do? It doesn't work because the buttons and the controls can't change.
I found a video of Scott Forstall and the Computer Science Museum, and he tells a funny story. Somewhere he's talking to somebody and describes that in some future state you can add a button to the phone, and they pictured that the phone must be made of Legos if you can add a button. Nobody could picture this software keyboard. So what Jobs is describing here is he wants a touchscreen keyboard that appears only when it's needed, one that can be modified based on the program that's actually using it. Now, the challenge was in 2005, no one ever built one that worked. Henri Lamoureux, Apple's vice president of iOS software engineering, gathered the entire user interface department and he gave them a single directive. He said, starting from now, you are all keyboard engineers. And from that moment, every other project was paused from a UI perspective. The backlog was clear, making typing on glass work. For the next month, the team produced nothing but keyboards. Every other day, they gathered to show prototypes, test them, and refine ideas. They called it the Keyboard Derby. It was a race of ideas conducted in the open. Everyone could see what the others had tried, what failed, and what was improving. They had a rhythm of near-daily demonstrations. Forced progress made this work audible. Transparency had become the process. An engineer named Ken Kocienda would eventually win the race, but only after 6 completely different keyboards. This is an experience he documented in a wonderful book called Creative Selection. This is my heavily dog-eared copy. Lots of notes. I've read it many times. Now, there's a teacher named Julian Dorr. He teaches a tech design class in Paris, and he got in touch with Ken on Blue Sky. And here's what he's asking. He says, hey, I teach this tech design class here in Paris, where your keyboard is one of the key innovation stories. I'm building a blob keyboard simulator. I want people to be able to feel this, right? He's also looking to bring transparency to his project here. And Ken Kocienda actually sends him this screenshot of an early keyboard. This is called the blob keyboard. It's pretty amazing here. So Julien Dora actually created this keyboard, and he has it up on his GitHub here, and he's got a demo. So I'm gonna type my name here. So this is pretty interesting. You notice that these keys are pretty large here. We'll talk about the importance of this and what he learned here. But you have to gesture. So I'm going to click it. You can do this if you go to the link in the show notes, or if you go to my website, you can interact with this. But it's pretty cool. So you have to grab the I here. I have to click and then drag up. I have to gesture up. So I'm going to type I. Think. Let's see. I'm dragging to the right here to get this K. What a time we live in to be able to interact with one of the early keyboard ideas from 2005. Now, I find the prototype a little tricky to use, and Ken did too. But the real value of this early concept is not actually its performance. It's what he learned from the feedback. And he got this feedback while demonstrating this to his peers. Some engineers had simply put a QWERTY keyboard on the screen. I've got some of these in because I have the, let's see, let me pull up the patent. So here's most of this is the patent for the keyboard here. It's filed in July of 2006. You can see there's a lot of names here. Ken Kocienda. I'm sorry, it's Ken Kocienda. Scott Hertz, he's also talking about this on YouTube. Bass Ordering very famously made the rubber band effect. When you get to the bottom of the screen, it kind of snaps back. Scott Forstall was the senior manager in front of all this. I'm surprised Henri's name is not on here. I've also heard Greg Christie talk about his experience. So here's an example of a QWERTY keyboard. It takes up a lot of space. And so the keys are very, very small. This is one of the problems with QWERTY. This is one of the problems that Ken ended up solving with autocorrect. But Ken found that these larger keys, through his with help from his department, he found these larger keys were actually easier, made typing easier. But this blob keyboard introduced new problems. You had to gesture to pick the letter you're picking. And that's the point, right? Ken's blob keyboard is exploring a different trade-off. The keys are larger. They're easier to hit than the QWERTY keyboard. But each contains multiple letters, and then it requires this additional gesture to select the letter you mean. The result was accurate tap targets, but with a mentally taxing interaction. You got to locate the letters in an unfamiliar arrangement. This wasn't a QWERTY arrangement. And then you've got to make that gesture, as I said. But the feedback from his team mattered. It showed Ken that there was value in larger keys, but a gesture-based selection was too slow and too cognitively expensive. And of course, his eventual solution would return to a traditional QWERTY layout. But to make the small keys usable, he would pair them with an entirely new concept, which we now know as autocorrect. About a month later, in that conference room at Apple called between conference rooms called a rock and a hard place, Ken Kocienda sat beside his boss's boss, Scott Forstall. They sat in front of an early iPhone prototype called the Wallaby. And Ken shared a picture of this on Blue Sky. Here it is. Here's this 2005 iPhone prototype here. See this right here? This is called the Wallaby. This is really just, there's a picture of it close up here, right? This looks just like the iPhone looked in 2007 when it was released. But in 2005, this is just a touchscreen. And all the software actually ran on this desktop Mac G3. They started with a G5, then they moved to a G3, which was a lot slower. They had to improve their software. Then they moved to a laptop, which had a slower processor even still. They had to improve their software to make it work, and eventually improving their software till it worked on what was capable to fit inside the iPhone itself. Other fun things I see here, here's an analog handset, right, which is tied to this PCB. So this analog handset is exactly what this prototype eventually makes completely obsolete. All this is wired, through this power supply to this Apple G3. This is amazing. Now picture this. Forstall spends more than an hour testing 14 keyboards, each loaded to this little thing called the Wallaby. And each had the same flaws. Keys are too small or they're too slow to use accurately. Ken's was the last to be demonstrated that day. And this is not Ken's first keyboard he's demonstrating. He's demonstrated 5 or 6 prior designs for his coworkers, and he made improvements each time. But this was the first demo for Scott, and I believe it's the first one on the Wallaby. Kocienda's bubble keyboard looked different from all the others. The keys were larger, but they had multiple letters on each. So he ended up moving to this QWERTY layout, but there's still different letters. There's still multiple letters on each key, but you no longer have to gesture to select. So Scott types these nonsense letters. He presses the AS key, and then the ZXC key, and then the OP key, and then RT twice. Where's RT? Here it is. Presses RT twice. And he looks up, and it says Scott. Then he hits the space key and a number of other keys, and he looks up again, and it says Scott is my name. He's flabbergasted. He asked Ken, how did it know what I meant? Kocienda explained that the system used a dictionary and would eventually use two dictionaries, a static dictionary of common words and a dynamic dictionary that learned a user's personal vocabulary. Ken said, the purpose was to help you type words. Ken said, the purpose was to help you type words in your own voice, to give you what you meant instead of what you did. Ken invented autocorrect to make a tiny touchscreen QWERTY keyboard usable. But that invention did not happen in isolation. It happened with two important conditions. One, the leadership set one clear priority. For an entire month, 15 engineers did nothing but make keyboards for an entire month. And the second condition was they had adopted this cadence of frequent demonstrations that produced constant feedback. The combination of clarity and rhythm made progress visible. Thus ended the keyboard derby. Kocienda's prototype became the foundation of the iPhone keyboard. It'd take him a year to refine it and to produce a shippable keyboard, but he demonstrated progress at every step. Apple's creative process was not mystical, it was transparent. And that transparency yielded two key insights. One, they had no working keyboard. Leadership could see the criticality of this and created urgency and focus to solve it. And two, ideas to improve would come from the whole team if we give them the opportunity. With this culture of demonstrations, they make a lot of things transparent. They make their backlog transparent. They need to make the keyboard work. Two, they make progress transparent by demonstrating every day, just with a simple method: build, show, learn, repeat. Three, they made their rhythm transparent. Everybody knew that this rhythm was steady and relentless. It made the work audible. I say this about knowledge work all the time. You think about physical work, right? You're building a house, you're pounding nails, and you can, like, the physical work has a sound. You're raising rafters. You can see the progress happening. But in knowledge work here, if you're not demonstrating all the time, you can't actually see the progress. This was Galileo's point. You need to make knowledge work audible. This is what transparency looks like in a creative process. Process does not kill imagination. It channels it. The iPhone keyboard was not born from a single spark of genius, but from the sound of a team learning in public. When I used to imagine creativity at Apple, I'd picture, some lone designer, Johnny Ive, or Steve Jobs himself, sketching some perfect idea. That's a myth. Apple's creativity was transparent and team-based. The iPhone in particular was a large team of teams. To maintain secrecy, very few engineers could see the entire product that was being developed. Many were genuinely surprised by features unveiled at the January 2007 keynote. But within each sub-team, the work itself was transparent. People could see their backlog, their priorities, and their progress. They had a method. They knew the rhythm. The rhythm didn't strangle creativity. It sharpened it. I love this story. I think it's fascinating. I mean, this is a keyboard that changed the world. These things are ubiquitous today. But it's kind of a sneaky, tricky problem that Ken Kocienda solved. That's all from me today. Thanks so much for joining the Lighthouse Leadership Podcast. I'll see you next time. Ciao.